A quadrilateral RSTU has vertices R51, S-1, 8, D-3, -1, and U3, -8. Use vectors to show that RSTU is a rhombus. So to start the question, we will write out each point as a position vector. So I can write S -1, 8 as vector S equals minus I being the unit vector, and plus 8j, j is also unit vector. Similarly, t -3 -1 can be written as t vector t equals -3, so -3i and -j. Then vector point u is 3 -8, therefore vector u can be written as 3i -8j, and r, which is 5, 1, can be written as r equals 5i plus j. So we got the points as position vectors. Now we got to find the vectors of the sides to see if they are parallel and equal. So we can see the opposite sides if they are parallel and equal. So we can do that. ST if I do. So that would be ST. I write vector ST that equals T minus S, and that would equal t is -3i, so -3i minus j and minus s, that's minus of -i and plus 8j, and that equals -3i plus I will open the bracket, remove the brackets first. So that would be -3i minus j and plus I and minus 8j. So then that becomes -3i plus I is -2i, and minus j minus 8j is -9j. So that is ST. So once I get ST, let me see what RU is. So is it the same? So RU, if I do, that would be U minus R, and that equals 3i minus 8j, that's U, and minus R means minus 5i plus j. So that equals 3i minus 8j and minus 5i minus j, that equals minus 2i minus 9j. So therefore ST equals RU, and ST is also parallel to RU because they are both the same vectors. So therefore ST, we say vector ST equals vector RU. So ST equals RU, and ST is parallel to RU. Okay, and then what we get is we got to do TUs. If I say what is TU, then TU would be U minus T, and U minus T will give me U is 3i minus 8j, that is T, that's U, and then minus T, so this minus of minus 3i minus j, and that would equal 3i plus 3j minus 8j plus j, that equals 6i. Sorry, this one is I, it's not j. 6i minus 7j. Okay, so that's du. So now I got to find SR to see if they're equal and parallel. So SR would be R minus S, and that equals, you have R as 5i plus j minus S, so that's minus of minus I plus 8j, and that equals 5i plus j plus I minus 8j, and that equals 6. What did I do? Did I get it right? Yes. Yeah, 5i plus I. 5i plus I is 6i, and then minus 7j. So I've written the I, combined the I and the I's and the J's in TU here, but I didn't do it here. But it doesn't matter. It's the resultant, the vector, the not the resultant vector. I mean, it's the result. You know, that should be equal. So TU is equal to SR. So therefore, we get TU equals SR, or vector TU equals vector SR, and also TU is parallel to SR, parallel to SR. So we got PQRS is a parallelogram. So therefore PQRS is a parallelogram. But it doesn't mean it's a rhombus. So rhombus is a special parallelogram where the sides, all sides have to be equal. So we have to prove the sides equal. That is, we have to prove now that the distances are equal. So to prove the distances equal, if I can prove only one of them equal, say SR equals RU, my job is done. So SR would be the square root of whichever way you take, minus 1 minus 5, minus 1 minus 5 whole square plus 8 minus 1 whole square, and that equals minus 6 square, that's 36, plus 8 minus 1 is 7 square, that's 49, and that is square root of 9 and 6, 15. That's 5 and 1, 4, 5 and 3, 8, square root of 85. So SR is square root of 85. Then what about RU? And RU equals again square root of, I can say 3 minus 5 whole square plus minus 8 minus 1 whole square. And that equals the square root of 2 square. So that's 4 plus minus 9 square, that's 81, and you see it is also 85. So SR equals RU, and therefore RU would equal ST, and SR is also equal to TU. So we get them all equal. SR equals, all the sides are equal, and therefore PQRS is not just a parallelogram, but PQRS is also a rhombus with all sides equal, so it's a rhombus.